3A does look a little bit complicated, but actually it's not. It's just a complicated drawing. So we've got an elastic rope that's fixed at one end at the top of a crane. The other end is connected to a block, which is initially at position A, so at the top. The block is released from rest, and it falls freely a distance of 60 meters. In other words, it's in free fall. So as it falls from the top, it's in free fall, so it's accelerating due to gravity. Okay. So it's saying if it starts off at rest up here with an initial speed of 0, what's going to be the speed after it's traveled this distance? And now I've put the symbols in. Hopefully it will become a little bit more apparent what we need to do. So we're trying to find the final speed v. So if I write out what I know u, I know the acceleration, I know the distance it's traveling, falling, and I'm trying to find v. Do I know time? No. Okay, so I'm trying to find this. The distance is 60. The acceleration due to gravity is 9.81, and the initial speed is 0. So it's v squared equals u squared plus 2as. So v is the square root of 0 plus 2 times acceleration due to gravity times by 60.0, and its speed is going to be, how many sig figs? We've got three significant figures, so 3 significant figures, 34.3 meters per second. 3b, we're trying to find the average resultant force. So the force is ma, which is sorry, didn't mean to put a bracket there, m v minus u over t. So we've got 80 is the mass, times by the change in speed. So 34.3 to 0. Okay, so 34.3. You could put the negative in there if you want, but you don't want it for the final answer, so I'm going to remove it. But officially, it's 0 minus 34.3. It's final minus initial, but I want the magnitude. And then divide that by the time, 0.759. So the magnitude of the force is how many significant figures? 3. 3620 newtons. Now, the average resultant force, we need to determine whether it's an upwards force or a downwards force. So we've got the weight pulling the block down, but we have said that officially that force here should have been negative, which means it's acting in the other direction to the direction of motion, opposite direction to the motion. So if the motion was downwards, then the resultant force is going to be upwards because it's in the opposite direction because it's negative. So what we're looking for is a nice straight line. Mine won't be straight, but yours will be. That's clearly a lot bigger, okay? Because we've got 3620 here, and the weight is 80 times gravity. So it's 80 G. So it's 80 times 10, roughly 800. So this wants to be much bigger. And if you want, you could, I mean, if you wanted to be perfect, you could make it kind of like 4 times bigger. Okay, so the average force exerted by the rope is a combination of what's trying to slow it down and then what's trying to accelerate it. So it's 3620 plus 80 times G, which is, I'm going to go to 2 sig figs because we've got 80 kilograms, so 4400 newtons. So 3E, describe the energy changes that take place between A and B. So at A, it's the point where it's at rest, at height. And at B, it's kind of mid-flight, if you like. So it's falling, sorry, with speed. So it's starting off with GPE, and it goes to kinetic energy. So what you need to write is the full words. Don't write GPE. And then the final stage is to recognize that the rope is being stretched, so it's going into elastic potential energy. So it really does need to be the full wording here. Oh, apologies, I've jumped the gun here. I've said it's going into elastic potential energy. I've just realized at B, it's still in free fall. So the rope isn't stretching yet. And then in B and C, we're getting the gravitational, I'll just pause it whilst I write it all out. We can see that the gravitational potential energy, oh, I've just done exactly what I told you not to do. The gravitational potential energy and the kinetic energy are actually moving across into elastic potential energy as the rope becomes stretched. So the speed starts to decrease and the rope starts to gain potential energy. Okay, 3G. Okay, so we know that at A, we have, now I will shorten the language because this is just my working. We have GPE only, and then at C, it's all gone into elastic potential energy. So what we can say is the GPE at A goes into or equals the elastic potential energy at C. And in order to find the elastic constant, that is the symbol K, and the elastic potential energy, E, equals half kx squared. Okay, so it was 1 mark to show you understood that, and the second mark